This is the next chart that I have to show how these two interact. Some ester groups, aldehyde, formaldehyde, and if you watch the one on the mixed clayson, this will be a little bit more clear to you. So this is a mixed aldol chart. So I'll just go ahead, go through the mechanism of the first reaction, and then I'll fill in the chart. This one's a little bit more tricky than the regular clayson and the mixed clayson, because you make an alcohol sometimes and sometimes you don't. You just make a double bond O. It depends on if the negative on the O, where at the beta carbon, if the electron can come down to recreate the double bond O or not, based on if something's leaving the beta. So, first step is alpha carbon. Find it. How do I know which one I can choose to be alpha? Well, the alpha carbon's always next to a double bond O. So between this one and this one, I have this carbon with its 3 H's, this carbon with its 3 H's. I have this carbon, but again, it's got 4 bonds already, so it can't be alpha. Therefore, this must be beta, or B, if you want to think of it. A goes to B, alpha goes to beta. It's like literally, sometimes it's like that simple. Most of the time, actually. It's always alpha going to beta, but sometimes the double bond O makes an OH. I'll show you in a minute. So this is alpha. We know it's alpha because it's next to a double bond O, and it has the most acidic hydrogens there, which means they want to be given away. So this is a base, and since this is an acid and base is going to come down, grab this H here, this is going to go here, this bond is going to come up here, become negative, it's going to come back down, and the double bond that was created here when this H went away does this, and this alpha becomes negative. So that was a little sketchy. I'll go over it one more time. The negative comes down, grabs an H. This H leaves. This free electron here gets drawn to here, makes a double bond right here. Since carbon can't have 5 bonds, it kicks this one up, makes it negative. The negative comes back down, and this double bond isn't going to stay. It's going to leave, so that this is negative. It has a free electron kind of chilling out there for just a split second, if you want to think of it like that. Since this is alpha, alpha goes to beta. So this goes over here, and it goes to beta. So the double bond from that carbon and that O gets kicked up. This becomes negative. Can it come back down? Remember, we just made a bond from the beta to the alpha. So there's 1 bond here, 2 bond there, 3, and we have this is like this, because it's negative right now, and it wants to come back down. If we did come back down with it, remember, carbon can only have 4 bonds. So there's 1 here, 2, 3, 4. So logically speaking, we already have 4 bonds. This negative can't come back down. It cannot, because if it does, it would want to kick something off, and there's no OET or like the OR group that can get kicked off. So we can't end up with 4 bonds if we recreate our double bond at that beta O. So what do we do about that? Well, we know that it can't stay O negative. It can't. So what you do here is, since there's an acid here, okay, the acid looks like this. It's a plus charge. So this goes like this, grabs an H, that goes like that, makes water, and this now becomes an OH. Okay, so the product ends up being this. This is beta. There's your H right here. There's your alpha, or A goes to B. So like literally just connect A to B. And that's the product. So hopefully that's clear. It should be. I'll go ahead and go through the rest of it real fast here. This is alpha. This is beta. So we say, okay, fine. Alpha goes to beta.